guys, today we're going to be talking about graphing rational functions with vertical asymptotes. Now remember what an asymptote is. We have been going over this. So an asymptote, whether it be vertical or horizontal, is going to be a dashed line that the curve approaches but does not touch. Okay, so it gets closer and closer and closer to this thing that we call an asymptote, but it doesn't actually touch it. Okay, so again, it's a dashed line that the curve approaches but does not actually touch. Okay, so today we're going to be talking about vertical asymptotes. All right, remember this is vertical and horizontal, but in this particular problem we're only talking about vertical. All right, we're going to talk about how we can go ahead and graph this function and how we can determine what the vertical asymptotes of this function are. All right, so the first step you're going to want to do here is you're going to want to factor. All right, so if you can factor the numerator or the denominator, you want to go ahead and do that. Well, looking at my numerator here, I can definitely factor this, right? So let's go ahead and factor this. And again, if you want to use the AC method here, you can. But as you get more and more comfortable, you may not need to. All right, so I'm just going to go ahead and factor this. So when we factor the numerator, we'll have the following. We'll have x minus 3, and then we'll have x plus 1. Okay? And this will all be over x minus 2. Alright, so there's a couple things now that we can see with this rational function. First, we know what the zeros are going to be. Okay, so remember, the zeros are where it crosses the x-axis. Alright, so the zeros are where it crosses the x-axis. And if you look at your rational function, alright, that's always going to be whatever you have in the numerator. So if I look at my numerator, I have x minus 3 and then I have x plus 1. Well, if I take this, I have x minus 3 and x plus 1, and I set it equal to 0, and I solve for each one of these factors, that's going to tell me where it's crossing the x-axis. So when I do that, I'll get the following. I get x equals 3 and x equals negative 1, right? Well, those are points I can now go ahead and put on this graph. So I'm going to go ahead and do that. Remember, this is where it's crossing the x-axis. So at x equals 3, so 1, 2, 3, we'll make a point, and negative 1. Okay? Alright, next step, we want to go ahead and draw in our asymptotes. Okay? For this particular problem, okay, we're only talking about vertical asymptotes. Alright, so this particular problem has no horizontal asymptotes, and we'll go into that further in future videos, how you can determine if you're dealing with a, if you have a horizontal asymptote or not. Okay, but just take my word for it, this problem does not have one. It only has a vertical. Alright. So looking at this, we want to look at our denominator. Alright, so an easy way to remember this, your vertical asymptote is always going to occur at whatever your domain is. So for example, your domain, if you want to find your domain, you look at your denominator, which is x minus 2, and you set it equal to 0. X minus 2 equal to 0. And then you solve, you get x equals 2. So what this tells me is my domain is going to be all real numbers except for 2. And that is going to be where my vertical asymptote is occurring. Okay? So if you had another factor here, let's say you had like x minus 3, well, you would take both of those factors and set them equal to 0. So you would have x minus 2 equal to 0, and you would have x minus 3 equal to 0. Right? You would solve x equals 2, x equals 3. So in this particular problem, your domain would be all real numbers except for 2 and 3, meaning you're going to have 2 vertical asymptotes. All right? But in this case, we only have 1, all right, and it's going to occur at 2. So why don't we go ahead and draw that in? So at x equals 2, we have a vertical asymptote. So let's go ahead and draw that in. So x equals 2, and we're going to make a vertical dashed line. Again, this vertical dashed line is an asymptote, okay? And the curve approaches it but does not touch it. Right. So we have that so far. We have our 2 points on the axis. Why don't we go ahead now and find a couple of other points so we can get a better representation of this function, and then we can go ahead and graph it. Alright, so what I'm going to do here, I'm just going to erase this bottom part, and I'm just going to pick an arbitrary point here. So why don't we go ahead and use our calculator here. So we're going to type in our calculator. We're going to put in the function as we have. So we have x minus 3 and then x plus 1. And this is all going to be over x minus 2. Alright, so let's go ahead and do that. So x minus 2. And what I'm going to do here for this particular problem, it's just much easier. I'm going to use the table value. So I just went ahead and graphed this in my graphing calculator and use the table value. And I can determine what's happening at a given point. So when x is equal to -1, I know that it's going to be 0, okay? Looking at my table here, when x is equal to -4, so when x is -4, y is going to be -2.4. So I can go ahead and make that point. So at x is equal to -3, I'm sorry, -4 rather, -4, y will be -3.5. So 1, 2, 3, 4, right about here. We have this point here. Okay. So again, I'm using my graphing calculator. You can go ahead and plug in these values into x. It might be a little bit longer, right? That's why I like to use technology when I can. All right. Okay, let's determine what happens when x is equal to 0. All right, well, when x is equal to 0, it's 1.5. So 1, 2, this is right about here. All right. At 1, okay, the function will be at 4. Right about here, and again, that is enough information to graph that side of the graph. All right, so we're going to have something like this. Again, it's approaching this vertical asymptote, and we'll have something like that. All right, does not be perfect, but you get a good representation of what's going on. All right, let's do the right side now. So we already have this point here, right, and we know that that's going to be at 3, right? At 2, we have our vertical asymptote. So let's go ahead and determine what's happening here. So if we go to 3, we have 0. At 4, we have 2.5. So 4, we have 2.5. Puts us right about here. Okay. At 5, we have 4. So 1, 2, 3, 4, 5. We're going to have 4 here. So put this right about here. So we can see kind of what's going on, right? It's going down and it's approaching, right, that vertical asymptote. And we have something like this. All right. And that is sufficient, all right? And that is how you go ahead and graph rational functions with vertical asymptotes.